Please welcome Michael Mann.
Well, thanks very much, Andy, and thanks to all of you for coming out. It's great to be here tonight, and I will be talking about my latest book, Our Fragile Moment, and what I mean by our fragile moment, what that moment is. And so we're going to be looking at Earth history. We're going to be looking back billions of years into Earth history, but you can't give a talk in Philadelphia about history and not talk about the role of this great city in our own history here in the United States. And I want to start out talking about Ben Franklin, and I'm required to do so because he did found the university that I work for. It's part of my contract. I have to always start out talking about Ben Franklin, but I love talking about him because, and this is actually an op-ed, it's online today in the Inquirer. It will be in the Sunday print issue of the Inquirer, an op-ed about Benjamin Franklin and his legacy and what he would think today when it comes to the climate crisis. He was arguably, America's first, or one of America's first climate activists. And what do I mean by that? Well, we all know he's a scientist. We all learned that story about the kite and the discovery of electricity when we were growing up, and it's only partly apocryphal. There's a fair amount of truth to the story, but he studied the Gulf Stream. Hundreds of years ago, he was studying the Gulf Stream. That's a depiction of the Gulf Stream by Benjamin Franklin. He was studying the atmosphere and weather patterns, and he was an environmentalist as well. He invented the eponymous Franklin stove, which was a more efficient burning stove, less smoke and air pollution. Same thing with that four-sided lantern. He invented this four-sided lantern, oil-burning lantern, that was more efficient and again produced less air pollution. He was also focused on water. He led a petition to stop tanneries from dumping their waste into the water supply, into the Philadelphia water supply. And to me, there's something extremely prescient about that, given what we experienced. Many of you will remember this event last year when there was a latex factory that had released toxic waste into a tributary of the Delaware. Fortunately, it wasn't detected in Philadelphia's water, but it just seems so prescient to me that hundreds of years ago, Franklin was actually thinking about these very things. He was thinking about air pollution, he was thinking about water pollution, and he would have been profoundly concerned about the climate crisis because it is impacting both of those things. Hurricane Ida nearly created a drinking water catastrophe because of contaminants that were potentially leaked into the water by the damage done by that hurricane, and of course the flooding, the historic flooding that was done. And this summer, some of you may remember, Philadelphia had its worst air quality ever. In fact, it held the title for several days. The worst air quality in the world was here in Benjamin Franklin's great city of Philadelphia. And I think that's profound because both of these things were, of course, climate related. That air pollution that was, in this case, from those Canadian wildfires that burned across Canada, which was experiencing record drought. You take summer heat, you combine it with record drought, you get wildfires. It's not rocket science. So we're going to do a deeper dive into history than just American Revolutionary history. We're going to go back not hundreds of years, but billions of years and see what sorts of lessons that offers us for this fragile moment we are in. Thousands of years, global temperatures were very stable. All of our societal infrastructure was built during that period of time and is dependent on the stability of the climate during the time it was built. And now, of course, we are rapidly warming the climate and leaving that envelope of variability that existed for thousands of years. And that's the real threat to our fragile moment. So let's start out by talking about when it begins. When does our moment truly begin? How did we get here? We'll go back to the Archean. This is more than 2.5 billion years ago, when, in fact, all the way back to 3.8 billion years ago, that's when life first emerged from the primordial ooze of the early Earth. That is when life on Earth began. Those microbes, those bacteria in the oceans 3.8 billion years ago are our most distant ancestors. All life came from that. But we'll advance to more modern history, only 66 million years ago now, not billions, but now we're into millions of years. The asteroid that struck the planet, we often say it killed off the dinosaurs. That's not quite true. We see dinosaurs every day. If you look out your window, you're probably going to see dinosaurs. It killed off the non-avian dinosaurs. In fact, all megafauna larger than a dog because of the dust cloud that was created and the cooling that resulted. We'll talk more about that later. But one important impact was, one species loss is another species gain. A new order of animals filled the niche that was left behind when the dinosaurs perished. Well, they weren't brand new, but they sort of took over as the dominant order, the mammals. The mammals, of course, we are mammals. They were our more recent ancestors, a little bit closer to us than those microbes in the ocean billions of years ago. There was a period about 10 million years after the dinosaurs died out. There was a sudden warming spike. It's called the PETM. We often point to that as an example of rapid warming. If we look to the paleoclimate record and we're looking for an analog where there was a rapid input of carbon dioxide into the atmosphere and a rapid warming of the planet, that's our best analog. But the warming today is happening 100 times faster than what we might call rapid in the geological record. Well, that rapid warming actually put selective pressure on mammals. It favored very small mammals, and a new type of arboreal mammal arose. This was the very first primate. So now we're getting much closer. We're getting to the primates. We are, of course, primates. This primate, you can see some fossils in this person's finger. This was a tiny primate, fit in your fingertip. When it's very hot, there's a selective pressure on organisms to get smaller because it's easier to get rid of heat. Well, that heat persisted. Not quite as hot as that Paleocene, Eocene thermal maximum. I know it just rolls off the tongue. That's why we call it the PETM. But the warm conditions persisted for some time. There were very high levels of carbon dioxide still, and there were expansive tropical forests, and so there was a niche for these arboreal mammals, the primates, to expand and become more and more dominant. The climate cooled off. Now we're about 35 million years ago, the Oligocene. Carbon dioxide levels are slowly coming down. So you can see carbon dioxide levels are coming down over a period of, on the order of 100 million years. All that carbon is getting buried beneath the surface. We're unburying it right now and putting it back into the atmosphere, but not over 100 million years. We're doing it over 100 years, 1 million times faster. I was going to title one section in the book, It's the Rate, Stupid, but my editor objected. So as climate cools, those tropical forests give way to woodland environments. And now you have a niche for large ungulates, horses that are running, and they are prey for other animals. Now we cool the climate even more. We're into the mid-Pliocene, only about 3, 4, 5 million years ago now, getting much closer. And we've got our first hominids, proto-human beings, proto-humans, expand as the climate cooled further, and those woodlands give way to savannas. And now there's a niche for animals like us that can develop hunting abilities and chase and pursue the prey on those open savannas. Now, I'm not sure if any of you saw the last Republican debate. there was a statement, actually this was made in a follow-up interview by one of the candidates, Vivek Ramaswamy, who indicated in the debate that he doesn't believe in climate change. I was asked to fact check this statement. Carbon dioxide as a percentage of the atmosphere is still at a relative low through human history. So I corrected that statement here. It's now correct as edited here. Carbon dioxide as a percentage of the atmosphere is the highest since Ardipithecus roamed the plains of Africa. Now it's a correct statement. Now it's a correct statement. Just required a little tweak. I'm happy to serve as Vivek's editor if he wants me to. Now we get into the Pleistocene. We're getting into the ice ages. We're into the ice house. And for reasons I won't go into here, but it has to do with changes in Earth's orbit relative to the sun that drives these big oscillations between glacial periods, like 20,000 years ago when an ice sheet nearly came down to Philadelphia, covered New York City, covered a large part of North America. There were expansive ice sheets. Global temperatures were several degrees colder than they are today. And we oscillate between those cold glacial periods with low CO2 and relatively warm, we call interglacial periods. And those oscillations create all sorts of challenges. Those huge swings in climate, those dramatic cooling events in particular, put selective pressure on the ability of those hominids and now hominids to become smarter, more efficient hunters, develop weapons that can be used to more efficiently hunt game, and communication so that they can communicate with each other. So it was those oscillations between glacial and interglacial climates that put so much selective pressure on those early hominids that it created the human brain. And we owe our existence. You can see in all of these examples, all of these accidents of climate history, that if they hadn't occurred, if these episodes hadn't occurred, we wouldn't be here today. So yes, it is true, we owe our existence to climate change, to natural climate changes. That does not mean that dramatic human-caused climate change today is good for us. Very much the opposite, as we'll see. So we'll skip past Gaia and Medea and the snowball Earth and the faint young sun. Fascinating stories, fascinating characters, including people like Carl Sagan and James Lovelock and Lynn Margulis. It's one of my favorite chapters, but we're going to skip to the Great Dying because it just sounds so fun, doesn't it? The Great Dying wasn't so great. It wasn't so great. This we call the end Permian extinction. It's at the boundary between the Permian and Triassic period, about 250 million years ago. And there was an extinction event. 90% of all species went extinct. In the oceans, 96%. Life was almost exterminated. It's by far the most extreme mass extinction event on record, the Great Dying. It's well named. And it's sometimes pointed to as sort of an analog for what we are doing today. And it is true, we are creating the threat of the next great extinction. Climate is part of it, but it's all of the other disturbances that we're introducing into the Earth system. We do threaten the next major extinction event. But sometimes people will point to the end Permian and they'll say this was a climate-driven extinction. Turns out it's not that simple. We'll get there in a moment. And it was due to runaway release of methane into the atmosphere. And this is what's happening today, and we can't stop it. We'll get back to that. You warm the permafrost or you warm the deep ocean, you release methane that was stored. Methane is a very potent greenhouse gas, so that causes more warming. More warming causes more release. And the idea is you get a runaway greenhouse, like Venus. Not quite that bad, but enough to extinguish, in this case, nearly all life on Earth. That was the paradigm for a number of years. There was some science that seemed to suggest that these methane feedbacks played a very important role. But one of the things in researching this book, it was remarkable to me how much progress there's been made over the last 10 years and how our understanding of many of these events has evolved quite a bit. And there's some things that were unique about the end Permian that we have to take into account. Gondwana, this huge southern hemisphere continent, and there were these early forests that had formed, the first forests at this time. And there was this warming and this drying of the continent and these forests. It's a very large continent. It's hard to get maritime air into the center of it. So these forests were sitting ducks. And we saw a massive forest die out, unlike anything that we've ever seen here in the modern world. And that did all sorts of things. It led to less burial of organic carbon, which it turns out means that there was a decrease in atmospheric oxygen, a pretty sharp decrease in atmospheric oxygen, and there was a dramatic decrease in ocean oxygen. Well, when you deoxygenate the ocean, then you create a niche for sulfur, hydrogen sulfide producing microbes, bacteria. And my former Penn State colleague Lee Kump has pretty convincingly shown that probably why you got that 96% die-off in the oceans, much greater than in land, was about 67%, and the average was about 90%. The oceans were about 96%, was because of a global stink bomb. If you've ever smelled a stink bomb or a rotting egg, that's hydrogen sulfide, and the oceans filled up with hydrogen sulfide. So you can see there's some things that happened during the Great Dying that are not good parallels for what's happening today, and not reason to suppose that we are ensuring our own extinction by comparison with what happened then. So what do we know now? We now know that it wasn't a huge methane-driven warming event. There was a large release of carbon dioxide. We are releasing carbon dioxide today through fossil fuel burning. Back then, there was a massive release of carbon dioxide through an unusually intense episode of volcanism, volcanoes that tapped into these carbon-rich reservoirs in the solid earth and pumped huge amounts of carbon dioxide into the atmosphere. Now again, this all sounds quite, it sounds quite remarkable. It sounds quite intense. We're adding carbon to the atmosphere 100 times faster, at least, than what happened then. So it's worth keeping in mind. It is the rate, stupid. It's the rate at which we are adding carbon to the atmosphere and warming the planet. But it was the carbon dioxide. The carbon dioxide is what caused the warming. And no, I won't go through the technical details of this graph here. I'm sure you're looking at that and it's like, what it shows is that if you look at the warming that took place during the end Permian, 250 million years ago, the circle is in the wrong place. There's 250 million years ago is right there. I need to fix that. It turns out that it actually validates the climate models today. It validates what we call climate sensitivity. How much warming do you get if you double the concentration of CO2 in the atmosphere, which we're on course to do later this century if we don't stop burning fossil fuels, potentially. How much warming do you get? We call that climate sensitivity. It's a basic measure of the warming effect of carbon pollution today. And it turns out that the models that we use today fit the Great Dying data very well. So you don't have to appeal to some huge runaway feedback. The warming was what we would expect it would be given the increase in CO2. It's all fuzzy and uncertain, but there's no reason in the Great Dying to question that the climate models are basically capturing the processes that were important back then and are important today. As my good friend and mentor, the great Steve Schneider, used to say, the truth is bad enough. The truth is bad enough. And yet we have doomers, climate doomers, and it was part of the original motivation of the book was to sort of, climate denialism is, has been somewhat on the wane, although there's a resurgence now in one of the two major parties and on social media. But climate denialism is sort of passé because the American people, they see what's going on. We see the impact of climate change. It's very difficult to deny it's happening. So the sort of polluters and those promoting their agenda look for other ways to, short of denial, to prevent us from moving on, from moving away from fossil fuels, keeping us addicted to fossil fuels. And ironically, one of them is doomism. If they can convince us it's too late to do anything, it potentially leads us down that same path of disengagement as denial. And so there's been an effort to, convince climate advocates and environmental progressives, the very people who would most likely be on the front line demanding action. There's been an effort to convince them, hey, it's not worth it. Don't bother. It's too late to do anything. And one of the arguments for that is that we've already triggered runaway methane-driven warming, and we know that that's what's happening because it happened during the Great Dying. That's all off. That's all wrong. The truth is bad enough. And yes, I am coming for your doomism, for your climate doomism, as the Philadelphia Citizen reported shortly before I started here at the University of Pennsylvania. The doomism, it may be the greatest threat right now to climate action, even more so than climate denial. All right, so let's move forward. We're gonna, now I'm looking around this room. I think some of you may recognize the song, the lyrics. Mighty Brontosaurus, don't you have a lesson for us? The Police, 1984, 83. Let's play it. Is it coming back? People remember this? So that was written by the Police back in 1982, in fact. Sting, Gordon Sumner, wrote the song in late 1982 on the island of Montserrat in the tropical Atlantic. And it was a parable about, it was a comparison of the asteroid that killed the dinosaurs 66 million years ago, and the destruction that was done by that event, and the threat of global nuclear war that was emerging in the early and mid-1980s. Now, I should point out that Brontosaurus actually died out 150 million years ago. That's 85 million years before the asteroid event. And if that sounds like a minor error, a minor mistake, we lived closer to T-Rex than T-Rex lived to Brontosaurus. They were farther apart in time than we were to T-Rex. But we'll forgive, a little bit of artistic license here is granted, especially for a song that was far more profound than most people probably realized. But that's what it was about. And it was really about the physical destruction that was done. Back in the early 1980s, the thought was global thermonuclear war. It would be the radiation, it would be the physical destruction, that would be the harm that was done. Well, you can see what the asteroid collision did, generated these shock waves around the planet. Those shock waves were so great that they created torrents. This is in North Dakota just a few years ago, a site, the Tanis site in North Dakota, where they discovered, this was a landmark discovery. There are legs of dinosaurs with their skin and scales intact. That's the skin of a triceratops that you're seeing below. There was an egg of a flying pterosaur with the embryo preserved within it. And there was a fragment of the asteroid that was found. Before then, all we knew was something happened. Things looked different after than they looked before. But this wasn't after or before. This was right at the event. This was a torrent that was created in where North Dakota is today, torrent of water from those shock waves, and all of these animals got caught up in the mud and the effects of this torrent and were preserved in this huge lump of, this mass of life that was killed by that event. So that's the physical destruction. And again, for a long time, the focus was on the physical destruction. But in the early 1980s, the great scientist Carl Sagan pointed out that the true threat of a global thermonuclear war would be not the physical destruction, but the massive dust cloud. And by now we understood that what actually killed the dinosaurs, it wasn't the physical destruction by the asteroid, it was the massive dust and material that was ejected into the atmosphere, rapidly cooled off the planet. Anything that couldn't burrow into the ground or down into the ocean died. And so it was a massive global cooling event. It was a climate change event. And what Sagan pointed out was that a global thermonuclear war would essentially do the same thing. And nobody would escape the effects of nuclear winter. You might escape the radiation if you didn't live near a large city. You might escape the physical devastation, but everybody would be impacted by nuclear winter. And he brought that to light. The popular parade insert in the Sunday newspapers, front page article by Carl Sagan about the threat of nuclear winter. He almost single-handedly, in late 1983, brought that threat to light. And that's when it came into the public consciousness. It influenced Ronald Reagan. It helped lead to the agreement between Russia and the United States to stop the escalation of nuclear arms. So Sting wrote that song a year before this parade article. He didn't know about nuclear winter. That was not yet on the horizon. They were just thinking of the physical destruction. They didn't realize just how profound that song was, because the real threat was nuclear winter, which was just like what actually killed the dinosaurs. These two threats, disconnected in time and space, but this eerie connection to them: the nuclear arms race and the threat of nuclear winter, and the asteroid that killed the dinosaurs. Now, there's a term to describe circumstances that appear meaningfully related yet lack a causal connection. It's the Jungian concept of synchronicity, the name of the album. All right, let's move on to the prologue, because it's getting late. So here's the thing. The dinosaurs didn't see it coming, and they couldn't have done anything about it, right? They had no agency. We don't have that excuse. We don't have the excuse that the dinosaurs had. We see this comet coming, if you like. If you saw the movie Don't Look Up, that's the analogy that was being drawn there. We have an uphill battle. If we had acted decades ago, if we hadn't succumbed to the misinformation and the disinformation campaign of the fossil fuel industry, if we had acted decades ago when the scientists already said we had a problem, it would have been easy. Look how gently we could have ramped down those carbon emissions and still avoided a dangerous 1.5 Celsius, 3 Fahrenheit warming. That's the level where we really commit to the worst impacts of climate change, and we're now really close to it. So if we had acted back then, it would have been easy. Now, that bunny slope has become a black double diamond. We've got to bring carbon emissions down by 50% by the end of this decade, by 2030, and down to 0 if we are to have any hope of holding warming below 1.5 Celsius, 3 Fahrenheit. Dangerous interference, truly dangerous, catastrophic global interference with the climate system. But it's still possible. And it's important to recognize that we are making some progress. We're not making enough progress, no question about it, but we are making progress. There's some good news that's come out of the science. Over the last decade and a half, there's been a major revision in our understanding of some of the fundamental aspects of how the Earth system responds to increased carbon pollution. In the old days, our climate models were very simplistic, and we would just turn up the carbon dioxide knob and see how much warming you get. And when you do it that way, what happens is the planet continues to warm up for decades, even after you start turning up the knob, because of what we call thermal inertia, the sluggishness of the oceans. They continue to warm up even after you stop turning up the dial. And that's all true, but what we didn't account for was the fact that the oceans are also taking up the carbon dioxide. They're pulling it out of the atmosphere. So if we stop emitting carbon dioxide, carbon pollution into the atmosphere, those carbon dioxide levels start to come down. The greenhouse effect starts to come down. Those two things, almost like magic, cancel out the committed warming that would cause increased warming, but the lowering of the greenhouse effect from the ocean uptake of carbon. The two things cancel out, and lo and behold, surface temperatures flatten when carbon emissions go to zero. There's a direct and immediate impact of our efforts to decarbonize our world. The warming stops, the surface warming stops almost immediately. So that gives us the agency that the dinosaurs didn't have. We can have a direct impact. The obstacles are not physical, they're not climate physics, they're not technology. We've got the technology to decarbonize our world. They're entirely political at this point. And political obstacles can be overcome. Perhaps they can be overcome in this upcoming election, which will determine the course of American climate policy and therefore world climate policy. The commitments that were made at the COP26 meeting 2 years ago were enough to limit warming now below 2 Celsius, less than 4 Fahrenheit. We were headed towards something more like 7 Fahrenheit before the Paris Agreement. The agreements we now have on the table, the commitments we have on the table are enough to nearly cut that warming in half. So that's real progress. But there are two things here, two problems. 2 degrees Celsius, that's still too much. Remember, I said we've got to keep it below 1.5 Celsius, 3 Fahrenheit. And those are commitments offered, commitments made, not commitments kept. And if we continue to expand fossil fuel infrastructure, the International Energy Agency has said that is not consistent with those commitments. You can't do both of those things. You can't commit to the carbon emissions reductions that you committed to and continue to expand fossil fuel infrastructure. So we've got a lot of work to do, but there has been progress. It is doable. And the greatest threat now is the notion that it's too late to do anything, and the disabling nature of that notion. And it really is, to me, it's about my daughter, it's about future generations, what sort of world we want to leave behind for our children and grandchildren. It's not too late to make sure that we live behind a, livable, flourishing planet, the planet that we grew up on. It's still a possibility to keep that, but it requires dramatic efforts now on our part. And so I will leave you with that notion, and then I guess we will go to Q&A. Thank you.
I want to start off, Michael, by asking do you have faith that we're going to stay beneath 1.5, and do you think we can hit what has been offered as the plateau and then bring it down?
Yeah, so I mean, sort of, follow up with what I, excuse me, follow up with what I was saying before. I'll expand on that. The obstacles are political, and so I remain, what I would call a stubborn optimist. Not a sunny optimist, not Pollyannish. I'm aware of the uphill battle that we face, the challenges we face. There is no path to, stabilizing the global climate that doesn't go through functioning democratic governance, for example. And so if we lose our democracy, and that's very much a threat right now, that all hinges on this next election. If we lose our democracy, then we lose any modicum of global leadership on climate. And if the United States doesn't demonstrate leadership, we've put more carbon pollution into the atmosphere than any other planet. Some people like to point the finger at China and say they're adding more pollution now to the atmosphere. That's true, but we've been doing this for 2 centuries. We've put more carbon pollution into the atmosphere than any other country, and that gives us an obligation to show leadership. And when we do show leadership, as we saw, for example, during the Obama years, then others come to the table. China signed on to a bilateral agreement that sort of set the stage for the Paris Agreement, which was, a monumental achievement. So I would say this. it all hinges on what happens, in American politics over the next several years, and it's up to all of us. If people who care about leaving behind a healthy planet for future generations, if they turn out and they vote in droves in this next election, then yes, this is absolutely doable. The technology exists. What we don't have right now are the incentives. The Inflation Reduction Act made some progress. It got us about half the way towards our commitment to the world. It didn't get us all the way there. In part, it didn't get us all the way there because there was sort of both carrot for renewable energy and stick for fossil fuels. And there was one, senator, who, many of you know, who sort of held all the cards because they needed 50 votes in a tie-breaking vote by the vice president. That meant that there was one coal state Democrat who basically had a veto on what sort of climate legislation could pass the US Senate, and essentially stripped out the stick part of it, which is really necessary to decarbonize as rapidly as we need to. And so if we don't like the fact that a coal state Democrat has essentially a veto on what sort of climate legislation can pass the US Congress, we can change that. And I would say, it takes individual action, right? But it takes individuals acting together, collective action. If we turn out and we vote in large enough numbers, then yes, that's the obstacle. If we can overcome the political obstacle, then we're there, because there aren't physical obstacles and there aren't technological obstacles. It's about what sort of incentives we have in place to accelerate the clean energy transition. There's quite a bit of work that suggests that it can be done. The infrastructure, the clean energy infrastructure that's needed can be put in place on the time frame necessary. It's just a question of the political constraints.
Thank you for your very motivating presentation.
Thank you.
I've been a climate activist for a number of years, and the thing that really frustrates me and some of my collaborators right now is that we are seeing that the fossil fuel industry is backed financially by banks, by investment funds, by government at state and federal levels that provide trillions of dollars of subsidies.
Yeah.
And going up against that, it feels like trying to take down a cement wall with a pop gun. I don't know what kind of strategy would be effective, and I'm wondering if you have any ideas.
So I do have some thoughts here. One of the things that we've seen, I think one of the reasons for optimism, if you're looking for reasons for optimism, and I see optimism in young folks, in the youth climate movement, in the way that they've changed the conversation. They've recentered it on, our ethical obligations. For too long, it was just about science and economics and policy, but they've made it about ethics, about fundamental ethical obligations that we have to future generations. And that has changed the conversation in a profound way. You hear stories of fossil fuel executives whose kids are asking them, Daddy, why are you destroying the world? That's got to have an impact on, and so those sorts of conversations are happening, and I think there's now a moral standard to which opinion leaders and influentials are being held that has the potential to change the game. When I was down in Australia, during what they call the Black Summer, you may remember when these wildfires sort of spread out across the continent, I had a number of meetings with the leaders of various superannuation funds. These are basically, they're like, what's the word I'm looking for? Basically, everybody in Australia has, all employers have to contribute a certain percentage of the salary towards, a pension fund. Thank you, a pension fund. It's basically just a pension fund. And some of the largest pension funds in the world, these superannuation funds, are in Australia because Australia has this requirement of employers that they have to contribute substantial amounts of money to them. And I met with the heads of those funds. And these are people who have children, they care about the world, they don't want to think that they're destroying the world, and they really want, they wanted to know, what can we do? What can we do here? Well, we sort of know what they can do. We have to stop funding new fossil fuel infrastructure. And, BlackRock has taken some steps in that direction. The Bank of England has taken some steps in that direction. And so I think there is a movement in that direction. And that's part of, the solution, because, we like to think that the solution will come from top-down policy, politicians, putting in place the right incentives. But it may be that as much progress comes from the business community, sort of stepping up their game. And there's some evidence that that's starting to happen. It's not happening faster enough, and it won't happen in total if there isn't pressure, if we don't keep that pressure on. And that's why those youth marches and protests are so important, because they're keeping the pressure on. What we can't do is put it all on the children, because they're not yet in a position to vote and to make policy. They don't yet have the influence that we do. We're in a position to change things now, and we have to take advantage of the opportunity that they've given them. They've sort of opened the door for us, but we have to collectively walk through it. That's the way that I see my own role as a parent. And I'm doing what I can, and we all have our own opportunities and our own ways in which we can impact the larger conversation, impact individuals, friends, people we know, talk about this, make sure it's on people's minds, put pressure on local politicians. There's so much that we can all do, and if we all do it together and we keep that pressure on, I believe that we can do this. We have risen to the occasion so many times in this country when people said there's no way you could win World War II, there's no way you could put a person on the moon. How many times have we risen to the occasion? We can do that here.
Hi, first I'd like to say from the bottom of my heart, thank you for your courage and for the work that you've been doing.
Thank you so much. Thank you.
Secondly, I'm going to confess that I have been guilty of doomism. But recently, I stumbled onto a small place in Florida that I'd like to mention, the Elizabeth Moore International Center for Coral Reef Research and Restoration. I'm not sure if you're familiar with them.
I think I might have heard of it, actually, yeah.
They're associated with the moat in Sarasota, but the lab is in Summerland Key. And I just want to mention it briefly that they're doing the most astounding work on breeding, not just cloning, breeding resistant corals. And the work they're doing in the lab, and my wife and I volunteer there and do diving with them, the work they do there and the work that they do in the ocean, it really gives me hope. And I offer it as a positive story for you in the audience. It's not over.
Thanks so much. Two things that I would say there. First of all, I recently wrote in an op-ed that, the antidote to doomism is doing. And this is a story of people doing things. Now, part of the solution is going to be adaptation. We have to prevent the warming that we can while being more resilient in face of those impacts that are now baked in. If we can slow down the warming, if we can, if we can limit the damage, then there is the opportunity for these sorts of coral reef restorations. All of these things can happen at the margins. In the absence of mitigation, reducing carbon emissions, it's going to be deck chairs on the Titanic. But it will matter at the margins. Because we will need to adapt to what's already baked in. What we're seeing now, that's baked in. That's not going away. We can prevent it from getting worse. But the other thing that I liked about it, and we had an event with our center just last week about climate stories, climate storytelling. Actually, we had two events, one with PBS and then another one with the Mitchell Center for Democracy, which involves some youth climate activists. And you may remember, you may have heard of the Montana case, where the very conservative Montana Supreme Court found in favor of these children and now require the state to take into account climate damage in any decision about new fossil fuel infrastructure. And we had the lawyer who argued the case, as well as several children, not children from the case, but other youth climate activists who are here in the Philadelphia area, here at Penn. And what won that case were the stories that those children told. And they were helped. The story sometimes has to be brought out of you, but each of them really did have an authentic story about how they had been harmed already by climate change. And, you know, it won over a conservative judge in a conservative state. If a decision like that can prevail in Montana, it can prevail anywhere. And by the way, the Constitution, the case was that the Constitution of the state has language that requires the protection of the air and water and the environment. Most state constitutions have similar language. So again, if you're looking for reasons for cautious optimism, there are things that are happening. You know, it's not just the executive branch and the legislative branch, but there are things that are happening on the judicial side of things, the judicial branch that are making a difference. And that precedent may lead to sort of a snowball effect in other states. So yeah, you know, you never know what's going, and that just goes to show you never know what it is that's finally going to break through and make a difference. And that was a real breakthrough, and it's a reason for optimism.
Professor Mann, thank you for getting the word out and the facts. I'm hopeful that we can convince the middle tier of the population to be more assertive voters for this. I was curious if you've ever collaborated with Dr. Mark Jacobson at Stanford. I know he believes that by switching the trillions of fossil fuel subsidies that we could shift everything with less cost by investing some of that into renewable energy. I was curious whether you feel as optimistic as he does about that. And I also believe he had indicated that he was writing reports for each state as to what they could do. So I looked for one for Pennsylvania, but I haven't found one. Do you have any feel for whether?
Oh, I think there is one for each state. I mean, I'll have to look into that. I know Mark quite well. You know, I have to say, he comes out of Stanford, and I went to UC Berkeley undergrad, so
a little competition there.
But it turns out that there's a group at Berkeley that has basically come up with the same, has come to the same conclusion that Mark and his group at Stanford have come into. It's a bipartisan agreement between the two universities. No, he has made a very compelling case, and I even sort of, I think I alluded to it. You know, the fact that it's doable. When I say we have the technology to do this, I'm thinking specifically about Mark's work, the Climate Solutions Project, which you're speaking of, which was also, there's peer-reviewed science by Mark and his group that's behind it. And it's been, like I said, it's been validated by other groups independently, his basic findings that we have the technology now to decarbonize our economy on the needed time frame. So there's the science behind it, but there was also a public relations campaign that involved people like Mark Ruffalo, the actor, and they really did get that out into the the center of the public discourse over climate solutions, to the point where like Mark's been attacked by some of those same fossil fuel interests trying to discredit his work because it's a threat. It says that we can do this. We can decarbonize our economy. I find it compelling. He does look at each state. Each state has a different mix of clean energy options. Some states are obviously going to be better on solar and wind. Others, geothermal is important. So he looks at each state and what resources they have independently. And so I'm quite sure that there is one for Pennsylvania, but now that you raise it, I'm going to have to find that or contact him, and if it isn't there, ask him why it isn't. But it's really important work because it is behind, it does support this notion that the obstacles are not the technology, as many like to say. Even Bill Gates, has done some helpful things, but when he says, we need a miracle to solve this problem, or that we're going to need geoengineering, because what could possibly go wrong there? It comes out of an odd, it's a techno-optimism that's selective for nuclear and for geoengineering and carbon capture. It's selectively optimistic about those things, but then you ask Bill Gates, well, what if we took existing wind and solar and geothermal and scaled it up? It's like, oh, there's no way you could do that. I've never understood the there's a myopia there that we need to wait on some new technology. And it's too often used as an excuse by polluters to kick the can down the road. Oh, we don't have the technology to do it now, but trust us, we'll fix this down the road. If you have seen the movie Don't Look Up, there's a whole sort of, there's a metaphor for that in what happens. I won't give away, I won't spoil the movie for those who haven't seen it, but there's a very important metaphor about the dangers of this idea that technology will magically solve this problem in the end, and using that as an excuse to not take the actions that we know we can take now.
Hi, Dr. Mann. Thanks so much for doing all of this. I've really enjoyed following you on Twitter in the last few months. And there's a guy named Will Stansel. I don't know if maybe you follow him, but I think he's just a random dude, basically. But he has been arguing that, I guess this is kind of a good follow-up to the previous question, but that, so it's a question about deploying renewable energy. So he's basically saying that right now, as we try to build out wind and solar, that the intermittency of those renewables is actually a problem, because when, for example, the sun isn't shining, right now it's like programming in a reliance on natural gas, because that's what fills the gaps when we're not getting energy from those two sources, and that the energy storage, actually exactly what you were just describing, that a magical new technology will come along and fill in the gap, that's sort of the situation we're in with regard to energy storage. And wouldn't it be better to build out reliance on a renewable where that's not a problem? What's your view on that argument?
Yeah, thanks for that question. And there is a lot of discussion out there along those lines. We actually, in our center, we have a scientist, Joe Rome, who actually founded the Climate Progress blog. It was a climate policy blog. It was sort of the first widely read climate policy blog a couple decades ago. He's now a senior research scholar at our center, and he's looked into this quite a bit. He's written about it. It's largely a myth. The intermittency is a persistent myth. It was an issue, but it's largely been overcome. I mean, there have been advances in storage. I think there still needs to be, so this is an area where we do need new technology. It will help, right? We can do this with the technology we have. It doesn't mean that new and better technology won't make it easier. And so we have to continue with that research and development. And certainly on the energy storage side of things, the first event for our center a year ago, when I first came to Penn, our very first event was with Malcolm Turnbull, the former Prime Minister of Australia. And he was a liberal, a member of the Liberal Party, and in the Southern Hemisphere, everything's opposite. So the liberals are actually the conservatives. Sort of means like neoliberal. The Liberal Party is the center-right party. But he was sort of like what I would call an old school, like a New England Republican, would be the analogy, pro-science, pro-environment. And he supported pumped hydro as a storage solution. So pumped hydro is a possibility. It isn't just batteries anymore. There's pumped hydro, there's molten salts. I actually do think that we need to look closely at green hydrogen, not to be confused with blue hydrogen, which is an excuse for continued methane extraction. But green hydrogen, the idea that when we have an excess of renewable energy, more than the grid needs at a given time, we don't want to just throw that out. We want to store it. And there are situations where hydrogen might be a good option, so we should be exploring that. But it's largely been solved, and you still have these myths. For example, you may all remember, actually it's one of the greatest examples of environmental refugeeism in US history, was when Ted Cruz flew off to Cancun to escape the Arctic blast a couple winters ago. But there was a criticism, of the governor and the state sort of energy system. They have their own grid that is separate from the rest of the grid, and it's overly reliant on natural gas. And you had conservatives in Texas trying to blame wind and solar. You heard claims, oh yeah, those wind turbines froze, and that was, no, what happened was there was a collapse in the natural gas supply line. The wind and solar both overperformed. They overperformed through that. In fact, the event wasn't as bad as it would have been because solar. And so there's a lot of mythology out there. There's a grain of truth, which is, yeah, we could do a better job with storage, and there are new technologies that'll make it easier. But this is the sort of thing, like we were talking about Mark Jacobson. I mean, he looks at, existing smart grid technology, existing storage options, sort of the whole picture. And when you look at the whole picture, where he comes down, and I find his arguments quite compelling, is we do have the technology now to do this, but it will get easier if we continue to research and develop.
So we are actually out of time, so we'll have to continue the conversation upstairs, but please join me in thanking Michael Mann.
Thank you so much. Thank you, everybody.